There are no arc fault circuit interrupter breakers, often called AFCIs, currently manufactured that are compatible with Federal Pacific Electric, commonly referred to as FP, Zinsco, or ITE Pushmatic electrical panels. These panels are considered obsolete and, in some cases, have been identified as presenting safety concerns. Therefore, replacing these panels is generally recommended, especially when modifications or additions are made to the electrical system, such as during a renovation. Any panel replacement should be performed in accordance with the current edition of the National Electrical Code, or NEC, and any applicable local codes. The NEC provides comprehensive guidelines for electrical installations, including panel replacements, to ensure safety and proper functioning of the electrical system. Replacing an obsolete panel involves several key considerations. Firstly, it's essential to determine the existing electrical load of the building. This involves calculating the total amperage demand of all the circuits connected to the panel. The new panel must have an amperage rating sufficient to handle this load, with some allowance for future expansion. A load calculation worksheet can be used to accurately determine the total load. Secondly, the new panel must be physically compatible with the existing wiring. This includes ensuring that the wire gauge is appropriate for the breaker size and that the wiring is in good condition. Any damaged or deteriorated wiring should be replaced. Thirdly, the new panel must be properly grounded and bonded. Grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. Bonding ensures that all metallic parts of the electrical system are at the same potential, minimizing the risk of shock. The grounding and bonding system must comply with NEC requirements. Fourthly, all circuits must be properly identified and labeled. This makes it easier to troubleshoot problems and perform maintenance in the future. Each breaker should be clearly labeled with the circuit it serves. Fifthly, AFCIs are required for many circuits in residential occupancies. AFCIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. AFCIs must be installed in accordance with NEC requirements. The NEC Section 210.12 details the specific locations where AFCI protection is required in dwelling units. This includes branch circuits supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, and similar rooms or areas. Combination type AFCI protection is generally required for these circuits, providing protection against both parallel and series arc faults. When replacing an electrical panel, it is crucial to ensure compliance with all applicable electrical codes and regulations. This includes obtaining the necessary permits and inspections. A qualified and licensed electrician should perform the panel replacement to ensure that it is done safely and correctly. Improperly installed electrical panels can pose serious safety hazards, including electrical shock and fire. While it may be tempting to try to find a workaround to avoid replacing an obsolete panel, it is important to prioritize safety and adhere to code requirements. Replacing the panel with a modern one that incorporates AFCI protection is the best way to ensure the safety and reliability of the electrical system. Here is a more detailed breakdown of the key aspects of electrical panel replacement and AFCI requirements. Firstly, assessing the existing electrical system. This involves a thorough inspection of the existing electrical panel, wiring, and grounding system. The electrician will identify any potential hazards, such as damaged wiring, loose connections, or overloaded circuits. They will also determine the existing electrical load and the capacity of the service entrance. Secondly, selecting the new electrical panel. The new panel should be sized appropriately to handle the existing electrical load and provide for future expansion. It should also be compatible with the existing wiring and meet all applicable code requirements. The panel should be listed by a recognized testing laboratory such as Underwriters Laboratories or UL to ensure that it meets safety standards. Thirdly, disconnecting the power. Before starting any work on the electrical panel, the power must be disconnected at the main service disconnect. This is typically located at the meter or at the main panel. It is crucial to verify that the power is completely off before proceeding. Fourthly, removing the old panel. The old panel is carefully removed from the wall. The wiring is disconnected from the breakers and the neutral and ground buses. The wires are labeled to ensure that they can be reconnected to the correct breakers in the new panel. Fifthly, installing the new panel. The new panel is securely mounted to the wall. The wiring is carefully routed and connected to the breakers and the neutral and ground buses. All connections must be tight and secure. Sixthly, installing AFCIs. AFCIs are installed on the circuits that require them, specified by the NEC section 210.12. The AFCI breakers are connected to the wiring and tested to ensure that they are functioning properly. Seventhly, grounding and bonding. The grounding and bonding system is carefully inspected and tested to ensure that it meets NEC requirements. The grounding electrode conductor is connected to the grounding electrode, such as a ground rod or a water pipe. The neutral bus is bonded to the panel enclosure. Eighthly, labeling the circuits. Each breaker is clearly labeled with the circuit it serves. This makes it easier to troubleshoot problems and perform maintenance in the future. A circuit directory is typically provided inside the panel door. Ninthly, testing the system. The entire electrical system is tested to ensure that it is functioning properly. The breakers are tested to ensure that they trip properly under fault conditions. The voltage is measured at various points in the system to ensure that it is within acceptable limits. Tenthly, obtaining an inspection. A final inspection is typically required by the local electrical inspector. The inspector will verify that the panel replacement was performed in accordance with code requirements and that the system is safe. It is important to note that working with electricity can be dangerous. Only qualified and licensed electricians should perform electrical panel replacements. Homeowners should not attempt to replace their own electrical panels unless they have the necessary training and experience. In addition to AFCI protection, ground fault circuit interrupters, or GFCIs, are also required for certain circuits in residential occupancies. GFCIs are designed to protect against ground faults, which are dangerous electrical conditions that can cause electrical shock. GFCIs are typically required for outlets located in bathrooms, kitchens, garages, and outdoor areas. The NEC specifies the exact locations where GFCI protection is required. When replacing an electrical panel, it is important to consider the need for both AFCI and GFCI protection. In some cases, combination of AFCI/GFCI breakers may be used to provide both types of protection in a single device. These breakers are typically more expensive than standard AFCI or GFCI breakers, but they can save space in the electrical panel and simplify wiring. The decision of whether to use combination of AFCI/GFCI breakers depends on the specific requirements of the installation and the available space in the panel. When selecting breakers for a new electrical panel, it is important to choose breakers that are compatible with the panel. Different manufacturers use different designs for their breakers, so it is important to ensure that the breakers are specifically designed for the panel being used. Using incompatible breakers can damage the panel and create a safety hazard. The amperage rating of the breakers must also be appropriate for the circuits they serve. Using breakers that are too small can cause nuisance tripping, while using breakers that are too large can overload the circuit and create a fire hazard. The wire gauge must also be appropriate for the breaker size. Using undersized wire can cause the wire to overheat and create a fire hazard. The NEC provides tables that specify the allowable ampacities for different wire gauges. When installing wiring in an electrical panel, it is important to follow proper wiring practices. The wires should be neatly organized and secured with cable ties or other fasteners. The wires should be properly stripped and terminated to ensure good electrical connections. All connections must be tight and secure. Loose connections can cause overheating and create a fire hazard. It is also important to avoid overstripping the wires, as this can expose bare conductors and create a shock hazard. The wiring should be protected from physical damage. Wires that are exposed to physical damage should be run in conduit or other protective enclosures. The conduit should be properly supported and secured. The NEC provides detailed requirements for wiring methods and materials. When working with electrical equipment, It is important to follow all safety precautions. Always disconnect the power before working on any electrical equipment. Use insulated tools to prevent electrical shock. Wear safety glasses to protect your eyes from arc flash. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, hire a qualified and licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent injury or death. In summary, replacing an obsolete electrical panel with a modern one that incorporates AFCI and AFCI protection is a crucial step in ensuring the safety and reliability of the electrical system. This process requires careful planning, proper installation techniques, and compliance with all applicable electrical codes and regulations. Hiring a qualified and licensed electrician is highly recommended to ensure that the job is done safely and correctly. It is also important to consider the long-term benefits of upgrading an electrical panel, including increased safety, improved reliability, and the ability to accommodate future electrical needs. Older panels may not have the capacity to handle the demands of modern appliances and electronic devices, which can lead to overloaded circuits and potential hazards. Upgrading to a new panel can provide the necessary capacity to handle these demands and prevent problems. Furthermore, modern electrical panels are typically more energy efficient than older panels, which can save money on electricity bills. They also offer advanced features such as surge protection and remote monitoring, which can further enhance safety and convenience. Finally, upgrading an electrical panel can increase the value of a home. A modern electrical system is a selling point for potential buyers, as it demonstrates that the home is well maintained and safe. Therefore, while replacing an obsolete electrical panel may seem like a costly and time-consuming project, it is an investment that can pay off in the long run in terms of safety, reliability, energy efficiency, and home value. Always consult with a qualified and licensed electrician to determine the best course of action for your specific situation. They can assess your electrical needs, provide you with a detailed estimate, and ensure that the panel replacement is done safely and correctly.